At this time, energy facilities have an increasing number of power transformers in very poor condition. The main cause of transformer failure is the decrease of polymerization of solid coil insulation due to the effect of acids which form when transformer oil ages. Oil plays a very important role in the transformer. Being a dielectric and a heat conductor, the oil is the primary means to maintaining the transformer in working condition. Transformer oils are complex hydrocarbon compounds which function under the influence of many physical and chemical factors. Depending on the load, with time transformer oil loses its qualities, its oxidation stability decreases, which in turn causes the oil to degrade quickly. In the long run, the oil and the products of its decomposition have an adverse effect on both the coils of the transformer and its metal structure. Energy facilities have been accumulating waste oil, which must be disposed of or recycled. The current situation in the oil market makes disposal of oil costly and inefficient. Besides, such disposal has a significant negative environmental effect. However, there are a number of technologies available today which allow the oil's characteristics to be restored. In most cases, the process requires the use of bleaching clays and sorbents. As a rule, the regeneration is costly in terms of time, labor, and energy resources. In some cases, the whole oil volume must be heated to above 110 degrees centigrade, then mixed with sorbent powders, settled and filtered, which is a lengthy process. Additionally, most of the sorbents are not recoverable and require further storage and disposal. Recoverable sorbents, such as silica gel and various zeolites, require significant energy for reactivation and drying, which can also involve a fire hazard. Besides the issue of disposing of and regenerating transformer oils, transformer overhaul also requires significant investment. As an alternative to the existing oil regeneration process, GlobeCore offers equipment based on percolation regeneration of transformer oils with Fuller's earth. This technology has the following advantages as comparing to the existing ones. After regeneration, physical and chemical parameters of the oil, such as tangent delta and acidity, exceed those of fresh oil. This technology allows regeneration of oils directly in the transformer. While regenerating the oil in the transformer, sediment and sludge are dissolved and removed from the transformer. Regeneration extends transformer life significantly while providing the required specifications. Fuller's earth can be reactivated up to 300 times. Reactivation restores absorptionability of the media. Sorbent is reactivated within the machine. No unloading is required. The reactivation process is safe and has significantly lower energy costs. Treatment is fully automated. Operator participation is minimal. The CMM-R unit is designed for oil regeneration. It is a collection of sorbent vessels and sorbent reactivation system. Filter, pump, muffler, charcoal filter, input and output pumps, safety tank, intermediary tank. The system is controlled from the control panel. It features manual and automatic operation modes. The manual mode makes all valves, pumps, and the vacuum pump accessible for direct control. Pump rotation speed is controlled with a slider. The panel displays oil flow, air pressure, presence of oil in the base, emergency shutoff, graphs, parameters, and malfunctions. 3 modes of operation are available in the automatic mode: filling, regeneration, and reactivation. Filling. This mode features automatic filling of the unit. The process is displayed on the process diagram. Regeneration. This mode features automatic oil regeneration. The regeneration process is displayed on the process diagram. Reactivation. This mode features automatic reactivation of sorbent. The process diagram shows all components involved in the reactivation process. The sorbent in the column is the primary agent in the system. During operation, the oil percolates through a stationary sorbent layer and regenerates and filtrates on contact. After regeneration, the oil goes to a filter for final purification from solid impurities and filtration of oil. After sorbent saturation by the products of oil decomposition, the system switches to sorbent reactivation mode. The sorbent is reactivated by igniting it and creating a strong airflow over it. Heating causes the sorbent to ignite, which purifies sorbent pores. Reactivation waste products are accumulated in a special collector vessel for draining. When reactivation cycle is complete, the system is again ready for oil regeneration. The sorbent in the system can be reactivated up to 300 times, which constitutes 1.5 to 2 years of operation until it needs to be replaced. The replacement process is simple. The sorbent is reactivated one last time and is unloaded from the columns in dry state. Waste sorbent is environmentally inert. It can be disposed of as construction site waste or household waste. The system can be operated as a standalone application for oil regeneration in oil facilities, but can also be coupled with a degasser. To couple the regeneration system and the degasser, the former is connected to a special bypass line in the degasser, and the system is started. When regeneration is started, the input pump directs oil to the sorbent columns. Molecular oil filtration takes place in the columns. At this time, the oil color is improved. After regeneration, the oil flows to the intermediary tank and then to final polishing. For oil treatment in a transformer or a storage tank, the degasser is connected to the above and the regeneration unit is connected to the degasser. After start, the units operate automatically, with all process parameters adjusted by automation system. When the sorbent reactivation is required, the bypass line is closed. After the bypass line is closed, the operator initiates sorbent reactivation process. Reactivation process runs as follows. The output pump drains the oil from sorbent columns and puts it into the buffer tank. After the columns are completely drained, the vacuum pump starts. The vacuum pump creates airflow for the columns. Then the sorbent surface heater switches on. At this time, sorbent reactivation starts and absorbed oil decomposition products are extracted. When reactivation process starts, the heating system switches off. The vacuum pump creates the airflow for sorbent reactivation. All oil decomposition products are burned and are expelled from the machine after catalytic breakdown into safe, non-hazardous compounds. Reactivation lasts until the sorbent cools down entirely, which is indicated by cold air in the exhaust system. After reactivation, the control system refills the system from the consumption tank and switches the unit into oil regeneration mode. During sorbent reactivation, the degasser continues to process the oil. Regeneration machines can be operated continuously. The only difference with a regular machine is an additional bank of sorbent columns. During operation, part of the columns regenerate oil, while the rest are in sorbent reactivation mode. After reactivation is complete, The machine is ready for operation again. The bypass line opens, the regeneration system and the degasser continue to treat the oil in tandem. This technology surpasses the existing systems in both quality for oil treatment and ease of servicing. The ability to treat the oil directly in the transformer is an additional advantage. Using the same sorbent many times saves labor costs related to sorbent replacement and eliminates storage and disposal costs. The efficient sorbent reactivation technology keeps the electric energy costs of reactivation very low. The design of the system provides for placement either on a separate trailer or in a standard 20 or 40-foot container. The unit can be used as a standalone application for oil regeneration in oil facilities. The Fuller's Earth oil regeneration technology is widely known and is used worldwide due to its high efficiency.